Today's video on regular expression to DFA. So to convert the regular expression to DFA, these are all the steps we have to follow in compiler design. The first step is we have to construct the augmented regular expression. Augmented regular expression means we have to mark the hash symbol at the end of the given regular expression. And the second step is we have to construct the syntax tree. So constructing syntax tree means in the syntax tree, interior node is going to be the operator and the exterior node, that is a leaf nodes, is going to be the operand. And after constructing syntax tree, the third step is we have to number all the leaf nodes. And the fourth step is we have to calculate four important functions for the conversion of regular expression to DFA. The first function is nullable function, second one is first position, third one is last position, and the fourth one is follow position. And these are all the formulas we have to follow. These are all the rules we have to follow for calculating the nullable function, first position and the last position. Totally there are 5 cases are there. The first case is if n is a leaf node and if it is marked with an epsilon, always the nullable function is going to be true. First position is going to be 5 and the last position is also going to be 5. And the second case is if n is a leaf node and if there is a position I, here nullable function is going to be false. First position is going to be the same position I and the last position is also going to be the same position I. And third case is if n is R node, for that node there will be a two child node, first one is C1, that left node is C1 and the right node is C2. In this case, nullable is going to be nullable of C1 union nullable of C2 and first position is going to be first position of C1 union first position of C2 and last position is going to be last position of C1 union last position of C2. And the fourth case is if n is a cat node or dot node or concatenation node. So for that concatenation node also two childs would be there, C1 at the left side and C2 at the right side. Here the formula for nullable function is nullable of C1 and nullable of C2. And for calculating the first position, if nullable of C1 is true, the first position is we have to calculate by using first position of C1 union first position of C2. In case if nullable is false, just we have to write first position of C1. In last position, if nullable of C2 is true, then we have to union the last position of C2 and last position of C1. If nullable is false, just we have to write only the last position of C2. And the last case is if n is a star node. So here nullable is always true. So for star node, the nullable function is always true. And the first position is first position of C1 and the last position is last position of C1. Because for star node always only one child will be there, that is C1. So these are all the rules we are going to follow for first position and last position and a nullable function. And now this is the rule for calculating the follow position. For calculating the follow position, we are going to consider only the two nodes, that is first one is dot node and another one is a star node. In case of dot node, the first position of C2, so for dot node, two childs always will be there, the C1 at the left hand side and C2 at the right hand side. The first position of C2 we are going to put inside the last position of C1. In case of if n is star node, then first position of C1 we are going to insert into the last position of C1. These two rules we are going to follow in follow position. So we are considering only the dot node and star node. We are not considering any other nodes here. So now this is an example I have taken for conversion of regular expression to DFA. The expression I have taken as a by b the whole star ABB. So first step is augmenting, construct the augmented regular expression, that is I have marked the n marker hash symbol at the end of the given regular expression. And second step is I am going to construct the syntax tree. So how I have construct the syntax tree? AB, that is A slash B, A by B the whole star dot A dot B dot B. So till now I have constructed A by B the whole star, A, B, B. And now along with the dot operator I have included hash also. So now I have constructed the syntax tree. So now I have to, what is the third step? Third step is we have to number all the leaf nodes. So I have numbered all the leaf nodes. For all the leaf node 1, 2, 3, 4, 5 and 6. So I have numbered all the leaf nodes. After numbering all the leaf node, what is the next step? We have to calculate all the function, that is nullable function, first position, last position and the follow position. To calculate the nullable function, so here always the nullable of star node is true and remaining all other nodes are false. So I have marked only the true node. So remaining all other nodes or all the interior nodes and exterior nodes are false. So now I'm going to calculate the first position and the last position. So if a node is marked with I position, so here all the leaf nodes are marked with the I position. Here this A node is marked with position 1 and B node is marked with position 2, 3, 4, 5, 1, 6. So if a node is marked with the position I, so how we are going to write the first position and the last position? The same I. So first is I. So 1 and last is also I. First is 2 and last is also 2. First is 3, last is also 3. First is 4, last is also 4. First is 5, last is also 5. And for this node, first is 6 and last is also 6. So now I have to calculate the interior first position and the last position for the interior nodes. So here the node is slash. In case of slash, so according to our rule, check the slash, check the OR node. According to our rule, the OR node is, the rule for OR node is, for the first position of C1 union first position of C2 and last position of C1 union last position of C2. That is for OR node, that is hash node. So first position of C1 union first position of C2, that is 1, 2. For last position of C1 union last position of C2. So that is 1, 2. Now the next node is star node. So in case of star node, our rule is we are having only one child node for the star. So first position is going to be the first position of C1 and the last position is going to be the last position of C1. So first position of C1 is 1, 2 I have written here and the last position of C1 is also 1, 2, that is also I have written here. Now we are moving for dot node. So what is the rule for dot node according to the given table? Check the table. So here for cat node, if nullable of C1 is true, then first position is first position of C1 union first position of C2, else only the first position of C1. And for last position, if nullable of C2 is true, then last position of C2 union last position of C1, else the last position of C2. This is a rule we are going to follow in cat node or concatenation node or dot node. So now we are seeing the next interior node as dot node and we are having two child node, that is C1 and C2. So here if nullable of C1 is true, so here the nullable of C1 is true because of star node. If nullable of C1 is true, what is our first position? First position of C1 union first position of C2. So that is 1, 2, 3. So I have written here as 1, 2, 3. So now for last position, what is the rule for last position? If nullable of C2 is true, but in this case nullable of C2 is false. If nullable of C2 is false, just I am going to write only the last position of C2. So I have written the last position of C2, that is only 3 here. Now the next is dot node. So if dot node, first we have to check whether the nullable of C1 is true. Here the nullable of C1 is false. If nullable of C1 is false, just we have to write only the first position of C1. So first position of C1 is 1, 2, 3. Here nullable of C2 is false. So last position of C2. So last position of C2 is 4. And here also dot node, nullable of C1 is false. If nullable of C1 is false, only the first position of C1, that is 1, 2, 3. I have written the first position for this dot node as 1, 2, 3. What is nullable of C2? Nullable of C2 is false. In case of nullable of C2, what is last position? The last position of C2. Last position of C2 is 5. So I have written 5. So here dot node, in this dot node, here also nullable of C1 is false. So 1, 2, 3, first position of C1. Here nullable of C2 is false. So last position of C2, 6. So now I have calculated the first and last position for all the interior node and the leaf node. So after this, we have to calculate the follow position. So how to calculate the follow position? These two rules we are going to follow for calculating the follow position. The first rule is if dot node is there, only for the dot node and star node we have to calculate the follow position. For dot node we are going to insert the first position of C2 into last position of C1. For star node, we are going to insert the first position of C1 to the last position of C1. So here I am traversing from top to bottom. So first I have encountered the dot node. So the rule for dot node is we are going to write first position of C2 to last position of C1. So what is first position of C2 is 6. And what is last position of C1? That is 5. So I am going to write the 6 on the node 5. So see here I have written 6 on node 5. And next I have encountered the dot node. So in this dot node, so what is the rule for dot node? We are going to insert the first position of C2. First position of C2 is 5 to the last position of C1. So I am going to insert 5 in node 4. So here I have inserted 5 in node 4. Then I have encountered one other dot node. So again in one other dot node, the first position of C2, 4, and I am going to move this first position of C2 to last position of C1. I am going to write this 4 in node 3. So I have written the 4 in node 3. Now I have encountered star node. What is the rule for star node? I am going to write just a minute. Yeah, in star node, the rule is first position of C2 to last position of C1. So see here, what is the first position of C2? First position of, in star node, first position of C1 to last position of C1. For star node, first position of C1 to last position of C1. So here I have written 1 and 2 and 1 and 2. So here I have missed only this dot node. So rule for dot node is first position of C2 to last position of C1. So I am going to write this first position of C2 to last position of C1. So I am going to write this 3 in both the nodes of 1 and 2. So I have written 3 in both the nodes of 1 and 2. And here in the slash node, what is this? Here in the star node, I am going to move the first position of C1 to last position of C1. What is first position of C1? 1, 2, and last position of C1 1, 2. So in both the nodes 1, 2, I am going to write 1 and 2, 1 and 2. So now I have calculated the follow position here. So here the syntax tree are constructed and we have calculated the first position and last position for all the nodes, and now we have calculated the follow position. So with this we are going to construct the DFA for the given regular expression. After making the follow, first we have to select the first position of root node from the syntax tree. What is the first position of root node from the syntax tree? That is 1, 2, 3. So here I have taken 1, 2, 3. And if you check the syntax tree, the node of 1, 2 and 3, so 1 is A, 2 is B and 3 is A. So here node 1 and 3 is A and 2 is B. Only two inputs are there, that is A and B. So among 1, 2, 3, 1 and 3 is A and 2 is B. So here I have marked 1 and 3 is A and 2 is B. And for this is the first new set. So I have given the name as capital A. So here I am going to find the transition of A comma A, that is for the new set with the input symbol A. So here A, where we are having A in node 1 and 3. So the formula is follow of 1 union follow of 3. So that results 1, 2, 3, 4. and this is another new set, that is B. Now transition of A comma B. So where we are having the node as B, only in node 2 we are having the input as B. So only the follow of 2, that is 1 2 3. For 1 2 3 we have already named it as A. So now we got one more new node, that is B. So now here we have to find out the transition of B comma A and transition of B comma B. So in 1 2 3 4, if we mark A and B, 1 and 3 is having the node A, and 2 and 4 is having the node B. So transition of B comma A is follow of 1 union follow of 3, that gives you 1 2 3 4, that is B. And follow of B comma B is follow of 2 union follow of 4, that gives you 1 2 3 4, that is another node C. So you are going to apply the same rule for all the for the C also. In C, 1 and 3 is A and 2 and 5 is B. So C comma A is 1 and follow of 1 union follow of 3, that gives you 1 2 3 4, that is an old set, that is B. And C comma B is 2 and 5, 2 union 5, that is B, that gives you 1 2 3 6, that is new set. So I have given the name as D. So now transition of D comma A and D comma B. So here in 1 2 3 6, 1 and 3 is A, 2 is B, and 6 is null symbol. So for D comma A, follow of 1 and 3 is A. So follow of 1 union follow of 3, that gives you 1 2 3 4, that is an old set, so that is B. And D comma B is only follow of 2, that is 1 2 3, that is also an old set, B comma A. So after this there is no other new set. So here we are going to terminate the transition operation. So from this transition operation I am going to construct the transition table. So here 4 nodes are there, A, B, C and D, with 2 input symbols A and B. So transition of A comma A is B, transition of A comma A is B, and A comma B is A. So A comma A is B and A comma B is A. So B comma A is B, B comma B is C. So BC. C comma A is B and C comma B is D. So BD. D comma A is B and D comma B is A. So BA. So now I have constructed the transition table. With the help of this transition table, I have constructed the DFA diagram also. From A to A, that is node A to B. Node A with the input symbol A, it is moving to node B. And from node A with input symbol B, it is moving to the same node. And node B with input symbol A, it is moving to the same node. Node B with input symbol B, it is moving to the next node C. And node C with input symbol A, that is node B. And a node C with input symbol B, that is moving to the new node, that is node D. And D to A is B. D to A is B and D to B is A. So now we have to select which is a final node. So here in the given nodes, which is having the end node, that is hash node. So according to the syntax, according to our syntax tree, here node 6 is the hash node. So here in D, in the set D only we are having this node 6. So D is a final node. So that node I have marked it as a final. So now I have converted the regular expression to for the given regular expression to DFA. Thank you.